Physicists believe that when time began, at the moment of the Big Bang, matter and antimatter were created in equal amounts. And based on recent measurements made at CERN Laboratory in Switzerland, it seems there is perfect symmetry between the two, which they say implies that our universe should not exist. What? Okay, here to talk about this perhaps disconcerting discovery is CBS News science and futurist contributor and theoretical physicist Michio Kaku. All right, Professor Kaku, so can you explain, first of all, what antimatter is and how is it different from the matter that we interact with every day?
Well, there's a Nobel Prize out there if you can figure out how this thing works. Antimatter is the mirror image of ordinary matter. It's extremely rare. If I had some in my hand, it looked like ordinary matter, has the same chemical properties, except if I touch it, it would explode and destroy all of New York City, parts of Connecticut and New Jersey. Every Star Trek fan knows that this is the greatest energy source in the universe, matter-antimatter collision.
Okay, all right, so that's it. Well, what is it about this symmetry between matter and antimatter that, leads CERN's physicists to this conclusion that we shouldn't exist, the universe shouldn't exist?
Well, at the instant of the Big Bang, there should have been equal quantities of matter and antimatter, which annihilated, driving the Big Bang. So, by rights, we shouldn't be here.
Right.
Because we have more matter than antimatter in our sector of the galaxy. We've looked for anti-galaxies. We've looked for anti-planets. We don't see any.
I don't even understand what that means, but okay, go ahead. Antimatter, anti-planets, because they would be made up of anti.
That's right. There should be anti-people, in fact. Anti-love, anti-CBS. But in fact, we see no evidence of that at all. So physicists say by rights we shouldn't exist. This means that at the instant of the Big Bang, there was a slight overabundance of matter over antimatter, and here we are as a consequence. Now, why? This is one of the greatest mysteries in all of physics. We are clueless to understand why. And like I said, if you want to win a Nobel Prize, figure this one out. Why was there's a slight overabundance of matter over antimatter?
Yeah, all right. Well, tell us more about these experiments that CERN is doing to answer, or at least try to answer, these questions.
Well, they take an atom smasher and they take the energy out of it and put it into a bottle. It's called a magnetic bottle. You can actually trap anti-hydrogen, anti-electrons going around anti-protons. And when they measure the property of anti-hydrogen, it's exactly like ordinary hydrogen, except, of course, they would annihilate it if they touched each other. And that's so frustrating. You want to tear your hair up. They were looking for an asymmetry between matter and antimatter. They find none. And so that's the mystery. Why do we exist at all? By rights, we shouldn't be here. By rights, we should have been disintegrated at the instant of the Big Bang.
Well, I'm sure there are all kinds of theories out there, but what are physicists kind of focusing in on? Is there one theory, two theories that are kind of the main focus?
Well, the leading theory is something called string theory, which is what I do for a living. I'm one of the founders of the subject, in fact, years ago. But even string theory has a hard time because you have to sort of like put it in by hand. And we want the theory to naturally come out with this overabundance of matter over antimatter, which explains why we don't see anti-galaxies out there and anti-planets. But we have a hard time doing it. So right now, nobody has a convincing answer to this question. Why should we be here?
Wow. Okay. Well, I won't ask you to give us a 30-second rundown on string theory because I think it'll probably take longer than that. Maybe we'll have you back sometime. But Dr. Michio Kaku, thank you so much for helping us understand this, or at least ponder the question, why are we here? Thanks.